Hello everybody, this is Mike Bartles from the Hydrologic Engineering Center. This video is a recording of a presentation that was made to a group of USACE water managers and hydraulic engineers that focuses on recent enhancements within HEC-HMS, many of which pertain to flood forecasting applications. Enjoy! We do have a couple of the HMS team members on the meeting too, so if you want to type in questions within the chat, we'll try and answer them there. If not, we'll try and get to them at the end. If we don't get to all the questions at the end, we'll definitely reach back out and make sure you get your questions answered. But I definitely want to say thank you for the invite and the opportunity to talk to you today about some enhancements that have gone into HMS that I think are relevant to forecasting applications. Simon's going to help me out as well. Simon is a huge success story. We've been able to expand our team like threefold over the past 2 or 3 years. And Simon came on as a developmental and added a really nice feature. I want him to show to you guys that'll definitely help everybody that has to deal with snowmelt. So quick overview and presentation today. Don't worry, I won't PowerPoint you to death. We'll go through a bit of the slides for sure, but I do want to actually do some live demo like we normally do. I think that works best for everything. But I do want to give a little bit of background because I would be reticent to not talk about a lot of the documentation and tech support and tech transfer activities that we've gone through to support the actual software. We'll get into some demo then, show you guys some of these cool new features. Some of them are within 4.9. Several of them are actually in the upcoming 4.10 release, but you'll have access to that right now if you're interested as part of our beta testing program. Save some time for questions at the end. All right, so a little bit of that background. The latest release is version 4.9. I know that's not the version that's within the latest SWIMS release. I think that's still 4.8, but there is nothing holding you back from updating to version 4.9. In fact, I would recommend that you do because we have a lot of bug fixes, not just new features and stuff, right? We have a lot of bug fixes that we put in every single release. And I would recommend that you update to version 4.9. Relatively straightforward. If it takes you more than like 15 seconds to make the change, something is going wrong, reach out to me. I can help you out. You can also use version 4.10 beta 2 within any SWIMS 3.x package as well. Again, it should be a relatively straightforward swap. You just got to delete your current HEC-HMS directory and your SWIMS executables, put this new one in, bada bing, bada boom, and you're ready to go. If you have any questions about that, let me know. If you're into Mac OS and Linux, I am not. If you are, we have Mac OS and Linux versions that are available for you as well. Everybody say thank you to Nick Van for making that one happen. Very, very nice thing. Included the link to our webpage here that you can go and grab it. I do want to note, please, please, please grab this portable version. If you get the first link, you will have to have admin privileges to actually use it. Hopefully you guys can see my mouse moving back and forth. Get the HEC-HMS 4.9 portable version, and you don't need admin rights to use it. You can move it, you can place it wherever you want. I would ask that you not put it in the C users profile, so not on your desktop because ACID shuts that down. You can put it basically anywhere else, and it'll work as intended, perfectly fine. The 4.10 betas, they're all of the portable variety, and you don't need admin rights to use those. So please grab those portable versions and give them a shot. Half of the equation in putting out useful software is providing documentation for it. And I'm not just talking about like, oh, click this button and this thing will open. That's part of it. We also want to make it accessible to everybody as well. So we spend a lot of time on documentation. I list them all out here, and they're available if you go to the HEC-HMS documentation page. There'll be links for all those guys there. But all of these things serve a purpose. Release notes, in particular, are meant to be a quick introduction to like what is new within this release or what bug fixes are within here. We spend a lot of time putting that into an easily digestible format, hopefully to garner some attention and get people interested in the new features that are out there. If you want the classical, I got to click on this button to open this dialog, and then there'll be these options within here. The user's manual is great for you. Go and check that out. That's also linked on the HEC-HMS documentation page. You can get to that way as well. The tech reference manual is where you're going to find a lot of the equations that provide the background of how these things or how these methods actually work behind the scenes. So if you're interested in that, we are actively updating that as we speak. Lots of new material that is being put up there. Very useful documentation to read through as well. The applications guide has some really cool stuff, and it has some actually really cool snowmelt applications and forecasting applications within there as well too. If you're interested, please let us know. If you want to submit another applications guide chapter, we would love to publish it. We'll put it up on our website for you as well. We have a few from international users as well, which is always really, really cool. So go and check those ones out if you're interested. And also, and people do ask for this quite a bit, prove to us that your computations are correct and they're repeatable and everything is on the up and up. That is our validation guide. If you're interested in reproducing what we go through on a day-to-day basis to prove that the changes that we make still produce accurate results and don't change things for the worse or anything like that, check out the validation guide that's available there. All these things are versioned too. So if you want to go and see what the user's manual look like for version 4.5, you can check that out. If you want to look at the validation guide for version 4.7, that's up there as well. You can scroll through all the different versions that are linked there as well. Tech support is a big, big deal for us. We spend a lot of time answering questions. We want to make the answers available for everybody, for our entire modeling community, and that includes people outside of the core as well. So I will ask you guys, please, please, please post your questions to Discourse. We get automatically notified when they're posted there as well. We do not get automatically notified when something is posted to Teams. You can post to Teams for sure, and we'll get to them and answer them hopefully in a timely manner. If you email us, we'll also answer your questions in a timely manner, but we're probably going to ask you to post to Discourse. And the reason being, we can do cool stuff like we have shown in the screen capture right here. So Jeff had posted a question asking if there was a file size limit for DEMs used for delineation within HMS. We get this question quite frequently because it's a pertinent topic for sure. A lot of people are doing this, which is great. But we get this question quite a bit. So what we can do is we can answer the question. We can also provide links to previously answered questions that are very similar in nature. So if you want to see what somebody else had asked, maybe it's a very, very similar question, just a slight quirk, a slight detail that's different about it, you can check that one out. And we can also throw in links to related questions as well. We can specifically designate that this is the answer as well. And anybody can respond back too with the usace.army.mil email address. You can get to Discourse. Any public user can get to Discourse. Only those that have a usace.army.mil email address right now are allowed to create accounts and post questions. In the future, we're going to open this up such that anybody can post questions. A limited number of people can answer them, but we're always looking for more people to help us do that. Be the tip of the spear and answering questions. You guys are really, really good. I was telling Andy before the question or before the webinar started, the SWIMS National Implementation Program has been an amazingly good thing for modeling within the USACE community. So many people have benefited from building models all throughout the country that there's a lot of knowledge that's out there. And a lot of people are really good at modeling. We would like your help answering questions. The answers don't have to come from HEC staff. Everybody that is knowledgeable should be available to jump into the discussion and provide, this worked for me type of situation. So if you're interested in doing that, reach out to me. I'd love to make you an admin of sorts that you can answer questions and we can get your help in doing that. Tutorials and guides are one of the main things that we focus on in terms of documentation. Obviously, we spend time on release notes. Obviously, we spend time on users manuals and stuff like that. But we write a lot of tutorials and guides to go along with new features and to also highlight these are use cases that we highlight, or use cases that we specifically want to bring to everybody's attention, and also the quote unquote way that we expect these things to be used, these new features to be used. Tutorials and guides are meant to be easily digestible. They're not verbose. They're not academic in nature. They're meant to be like readily accessible for engineers, right? I don't want to have to scroll through 10 pages of gobbledygook to get to the point where it actually makes sense and works out and I want to see what's going on. Tutorials and guides are meant to do that. We have many, many, many that are on our website. Just growing day by day too. And we also keep them up to date as well. So if you find one that maybe has a typo or an issue in it, we can easily correct it and it's live for the world to see in 30 seconds as well. We also get a lot of help from partners that are outside of HEC that develop tutorials and guides for us for interesting features. We've been getting a lot of really good ones, for instance, from folks in the St. Paul district. Great additions here as well. We'll have one soon on the other side from the Fort Worth district as well, if not already up there. Some cool new precip frequency options that are up there too. So lots of cool stuff and lots of opportunities for collaboration. If you're interested in writing a tutorial and guide for us, doesn't have to be long and complicated or anything like that. Some of these are meant to be read in 5 minutes. Let me know. We'd love to put it up on our website. We've also done a lot of work in posting training materials. So I highlight here the basic HEC-HMS class materials. That goes along, the things that I'm showing here are specific lectures that we have in video format. Some of them are 5 minutes. Some of them, as you see here, there may be like 15 minutes or so, but they're all shorter lectures. They're not meant to be, an hour-long PowerPoint show and tell or anything like that. These are meant to be, quick, get at the feature that we're trying to show you or the details that we're trying to show you and get to the point relatively quickly. This is for the basic HEC-HMS course. So if you guys have any coworkers that have been wanting to take this course and can't get into it, we only have so many slots that we can do each year. But if you have coworkers that are interested in this course material, it's all on our website. You can go check it out. We also link to all the workshops that we would go through. They have solutions that are up there as well. You can go and look at the stuff on your own time. You can rewind and watch the same part again until it makes sense. Ask us questions about it. The link to the material is shown down there at the bottom. Please take a look at that. Let me know if you have any questions. And I think the last thing that I wanted to highlight for tech transfer is our quarterly webinars. We've been putting these on since February 2021. We just gave our 6th quarterly webinar earlier in March. We are intending these to increase awareness of new features and materials. There's a never-ending list of things that we would like to show and have people experience and have a good time actually using the software and show off new stuff. Right, so we focus on 2 to 3 new features, and demo their usage as well, and then we have time for Q&A at the end. I have a link here to our quarterly webinars page, so I just posted the March 2022 video. If you missed it, they're all there. If you want to go back and rewatch any of the older ones, they're all there as well. We also include the PowerPoint if you want to look at the slides that go along with it or any of the notes, anything like that, they go there too. So definitely hit that one up. All right, enough PowerPoint for now. I'm going to demo some of these features. Wanted to give a shout out to the folks that actually paid for these features and say thank you. A lot of the features you're going to see were funded by FEMA. Some were funded by the HH&C SET Science and Engineering Technology Program, the SWIMS Natural Implementation Program, obviously, and the Risk Management Center. Definitely threw some funding down to get some of these things incorporated. All right, so the first project that I want to open up is one that has a lot of gridded data. I want to talk about what we do if gridded data isn't necessarily in the format that we want it to be or has some problems that go along with it. So while this project is opening, you'll see a file references dialog show up. In the past, we have definitely shown, hey, something is wrong with this. There may be some data that's missing or whatever else, or we can't find a specific file. This has changed recently. It used to be just like fix this link and click OK or cancel. If you click cancel, we would have replaced that DSS file linkage with the project DSS file. So it would have gone to UKR-HMS-UKR3-DSS. The compute would have failed and the link would have been broken and you would have had to go on and fix it. We don't do that anymore. So if the link doesn't exist, so this one is shown in red, that file doesn't exist on my computer. It's not there. We will show you when you open the project that this thing doesn't exist. I can close that and I can still go into grid data, go to the specific one that's broken, and we haven't changed that. We let that go. That's still broken. The compute will fail for sure, but we're not going to change that to the default project DSS file. We just let that go in there. Notice that the entry field, the text in there is highlighted in red. That's meant to bring your attention to it. Red is usually a bad thing. It's a bad thing in this case. The data doesn't actually exist there. We have other color-coded text strings as well. So if I were to go to the liquid water content grids, this one is shown in orange. It's probably kind of hard to read, but this file name is shown in orange here. Orange indicates that the file does exist. We can find it on the machine, but it's not within the HMS project directory. We are asking users to put data within the actual HMS project directory, mainly because if you go to give this to somebody else, you're likely just going to zip up the HMS project directory and give it to them, or copy and paste it onto some location or whatever else like that. That doesn't necessarily bring along files that are external to the HMS project directory. So we're going to call your attention to this thing does exist, but it's not where we think it should go. We want these things to go within, go to this guy. We want these things to go within this data directory. So we now actually create this by default. So if you go into here, this is where we're expecting you to put this data. It can live elsewhere and HMS can actually function, but if you put it in here, this is a nice place for it to go. Please throw your DSS files that you need within here, and it'll be all good to go. If you look at other grids, for instance, let's click on this one. Simple black text, that means, hey, it's all good, we can find it, and it's also within the HMS project directory. So you remember that we had that one broken link down here, this guy shown in red. You can go back to see that same dialog before. So if I go to File and then References, that'll open up that same dialog that you saw before, and you'll be able to do a whole lot of fixing within there as well. So there's a lot of data within this project, and I wanted to highlight that because there are many, many projects that we see that have lots and lots and lots of data, whether it be time series or paired data or gridded data. There's a lot of different references to different files. So we allow for filtering. You can go down to invalid references, so that would show the red text here, just that single line. This is the one that doesn't actually exist. That's an invalid reference. If I wanted to see just grid data, I could filter to just grid data, or paired data or time series data. It's in here as well. So that we'd limit this dialog to just include that data for you to fix the individual files that you want. You can fix them, you can click in here, and we have this file selection dialog. You can just change the string if you wanted to. If you wanted to change that guy, you can go through and do it. Or you can click on the file select dialog and go to where it needs to be. That's not the only data that we actually show in here too. So if you scroll down, you see we have all this paired data stuff in here, and we actually list out like what the thing is. So this is a storage outflow curve. This one's an ATI melt rate paired data function. This one's elevation storage, so on and so forth. You get to your gauge data. So this is like time series information. That's all good. And now we actually get to like, these are the output DSS files. So you can see where they are. Obviously they exist because we put them there, but you can also see any like file specified discretizations. So that's a classical, .mod file. Those are all in there, and we list them out for all the subbasins that are actually using a file specified discretization. So you can see a lot of data within this file references dialog. One last thing that I want to show you for data as well. If you're like me, you've had computes fail in the past because data just wasn't correct. It had changing extents, or the lower left corner changed, or the units changed halfway through the compute and it failed, or whatever else like that. And you only see it after it's been computing for a little while, which is kind of a bummer. Now you can actually screen your data beforehand to see if it's good to go. So there's this grid record validator that's available for use. So I right click on the grid that I want to actually validate and click on the validate option here. And it says, hey, this file doesn't actually exist. It's not valid. That makes sense. That lets me know beforehand, right? Before I actually click compute, it's ready to go. But I can go to one that actually does exist. I can click validate, and it actually loops over that to see, do the extents change? Do the units change? Does the lower left corner change? Anything like that? Does that change? No, it's valid and it's good to go. I can do that for temperature grid sets too. So I'll loop over this file and look for these path name conventions. So the A, B, C, and the F part, and I'll see, do all the grids that fit those conventions, are they actually legit and valid? This one is. Let's look at one that isn't. So if I right click on that and say validate, you start to see a whole bunch of red text come up here. So this specific example, the extents and the lower left corner change at the beginning of each month, which is kind of a bummer. So at the beginning of May, the extents change. That's not good, because if we had a compute span that time frame, you would go from one extent to another and the compute would fail. Same thing happens in June, same thing happens in July, same thing happens in August, and the same thing happens in September. So we give you an indication up front that that grid record is probably not good to use in here, and this is why it's not good to use. So we let you know before you actually click the compute button. And you saw how fast that went. So that was super, super quick. We can loop over those records and let you know before you actually get to the computations. Hopefully that can save you some time. All right, so that was file management. Next, I wanted to talk about interpolated meteorology. So let me click on that project. And while that's loading, I'll actually go over here to these slides. So interpolated meteorology is very similar to if you've used the classical program GaugeInterp. I love that thing. I use it a lot in the past to use gauge data to create grids for use in gridded modeling or gridded boundary conditions. I use it a lot for precip and temperature. Really, really work great. We've integrated that within HMS. The same computational engine that GaugeInterp used has now been integrated within HMS. So you can distribute precipitation and temperature grids to, or precipitation and temperature gauges to create corresponding grids. But it also works with other meteorologic variables. And I'll show you that in a second. There's two that we haven't done yet, but we'll get there really soon. And we also have tutorials that you guys can check out for these. This is where our partners at the St. Paul District are really helping us. So very, very thankful to them for these uses. We can do some special stuff with precipitation and temperature gauges. I'm going to talk about that for a really, really quick second. All right, when I talk about precipitation bias correction, what we're specifically trying to do is account for the fact that we don't have gauges always where we want them to be, right? Sometimes it just so happens that the gauges are in the populated areas, but we expect it to rain a whole lot more where there aren't people located or there aren't gauges located in there. So the example that I'm looking here is the Truckee River watershed, and behind it, I'm showing a normalization grid that shows expected precipitation accumulations over a single year. And what I want to highlight is the fact that normally in this region right here, we typically would expect about 100 inches of precipitation to fall. Whereas over here in this big red blob on the side, that goes down to about 4 inches in a year. That's a crazy gradient. This is because the Sierra Nevada mountains are right here. So you have warm, moist air masses coming across California. They want to get over the mountains. They have to go up in elevation. That means they have to drop precipitation out to actually do it. That's why it rains so much here. That makes sense. But you also have these high elevation, and I don't want to call them anomalies, but they're mountains that are within kind of a lower elevation area. This one in particular, where I'm hovering my mouse, that's called Mount Rose. So elevations there go up to about 10,000 feet. If I were to do a straight line interpolation between these two gauges, which are relatively lower in elevation than the surrounding areas, I wouldn't be accounting for the fact that I expect precipitation to fall more heavily in the higher elevation areas. That's what the precipitation bias does for you. It adjusts those grids according to the actual bias grid that's behind the scenes to account for the fact that we don't have gauges where we always expect them to be. It's a similar concept for temperature. I'm sure you guys have looked at this before. I'm sorry if I'm boring y'all, but I want to make sure that everybody knows what we're talking about when we go and look at the component editors. For this case, for the Truckee River watershed, for this time period in question, I only had about 5 temperature gauges to work with. So I want to distribute temperature between these gauges and around these gauges, but I don't really want to do like a straight interpolation, like a line of sight interpolation between, say, this gauge is near the city of Truckee and this gauge over here that's near the city of Reno. We expect temperature to change quite a bit according to elevation, especially when we go from about 5,000, 6,000 feet in elevation up to like 10,000 feet in elevation. It's usually much colder when you go up to like 10,000 feet than it is at, in the valleys at 5,000 or 6,000 feet. So if I were to interpolate between this value and that value without taking that into account, I would likely melt way too much snow in the Mount Rose area. So to adjust for that, we use this LAPSE adjustment. And what that does is essentially adjust everything down to sea level. and then does the interpolation, and then adjusts it all back up again to adhere to the fact that we expect temperatures to decrease as you go up in elevation, or at least change. The typical convention is that you expect them to decrease as you go up in elevation, but you can specify that within the user interface. All right, so what I want to show here is if I open up, first I'll show you the basin model so you can actually see where we're going. So this is the Truckee River watershed here, and I actually have a couple of the precip gauges that are shown here in yellow, which is a super hard color to see. I'm sorry, they're back there. We don't really need to see them. If I go and look at the meteorologic model and click on that node, we have split out also. I don't know if you guys have seen this or not, but this was a version 4. It started in 4.8, but we got it actually integrated within 4.9. We've actually separated the meteorologic components. No longer do you have, multiple choices for temperature. Say, what is my temperature choice to use for evapotranspiration processes, for snowmelt processes? It's just, you get one shot at it, as it should be, right? What is the way in which you want to define what the temperature is at any given point in any given time? And the snowmelt method can ask for that. And the evapotranspiration method can ask for that. You don't need to set that a whole bunch of different times. You just do that once. Same thing for, say, shortwave and long wave radiation, or wind speed, or air pressure, or whatever you want to do. Whatever process you want to define in here, it's all set up. In the past, say for precipitation, I think most everybody was using gridded precipitation, or in some cases specified hyetograph, where it was saying, this is the precipitation time series to use for this subbasin at all times. Now we've added these interpolated options. So if I wanted to select the ability to, say, use something similar to gauge interp, I would do that interpolated precipitation option. Same thing for temperature. In the past, I think most people were using gridded temperature. If you wanted to do snow melt, or if you wanted to look at evapotranspiration using the gridded Hammond method, you would be using gridded temperature here. You now have the option of interpolated temperature, which is using gauges to create those grids for you. If I select the interpolated precipitation node, this component editor fills out with my choices for the actual method in play. First and foremost, I got to choose how I want to interpolate between these points. Inverse distance is a pretty typical selection, but you can also do IDW and IDW squared. You can also do nearest neighbor or bilinear interpolation as well. However you want to distribute that temperature, that's all good. You can also bias precipitation. So this adjustment method is specific to the precipitation choice here. That's not available for temperature, so you can't bias correct temperature or anything like that, or apply a bias grid for temperature. You can only do LAPSE for that, but I don't have to if I don't want to. We would suggest that you do, but you don't always have to. And then you would select a grid. So we added a new gridded object as well, or a shared data object for precipitation normals grid. So this one comes from PRISM, which is the parameter regression on independent slopes model, which is great. Really, really good source of data. If you've never seen it, check out their website. I can send you a link to if you guys want it, or I can just give you the DSS file that I got here anyways, and you can use it. But this is a distribution of expected or normal precipitation accumulations per year across the entire continental United States. This is a pretty good way of saying, like, if I have a gauge here and I have a gauge there, I can interpolate between the two, and I would expect it to change this much in between. Maybe you don't want to interpolate between the Central Valley and middle of Nevada. I would suggest using more gauges than that. That was just an example. This would still work on a very, very small and localized case, which we're talking about here. We'll actually clip that grid for you as you compute to just the modeling domain of interest, right? So this is the entire grid for the entire continental United States. I didn't clip it beforehand. I just threw in the grid for the entire US. It'll clip it when we actually go to do the compute. You would select the gauges that you want to use, and they're all going to be found within time series data precip gauges. So all these guys in here are available for selection. Every single one of them needs to have a latitude and longitude, which you specify within the time series precip gauge component editor. Knowing that, we know where it is, and we can actually do all the computations we need based upon its location. You also want to specify a radius of influence, which is used within the interpolation method. And it'll figure out where they all need to go, or what the values are in between each gauge. It's a similar component editor for interpolated temperature. Again, I only have like 5 gauges in this case, so not a whole lot to choose from here. But instead of using the bias correction, I'm using a lapse adjustment for temperature. And this lapse rate here says this is how much I expect temperature to change for every 1,000 feet of elevation. So as I go up in elevation, I expect temperature to decrease in this case. That's pretty normal. Standard values are somewhere around in this range. If you're using anything crazy, be careful with it. But this is a pretty standard value that I would get. And I actually plotted it up against observed data to figure that out too. Similar setup, I want to choose the gauges and the actual radius of influence when I go and compute. So let me actually do that. So if I select the simulation that actually uses this MET model and I go and compute, you'll notice in the actual progress bar, after we get through doing all our basic checks of like what the data is and is it all valid to use and all this kind of stuff, you'll see it go really, really fast, but we compute the meteorologic model first. So you saw performing interpolation. That was the process of actually distributing those precipitation and temperature observations to create grids. So that happens super, super fast, right? The cool thing is we don't need to do that every single time you compute. So if you don't change any of this stuff, we don't need to compute those grids again. Actually write them out the disk for you. So I'll show you that here. So if I go to the project and then go to the MET model DSS file, this January 1997 gauge interp DSS file, I'll open that up. We'll take a look inside there real quick. You can see all these grids, right? These are the ones of interest. I can also go to temperature, and these are the temperature grids. We're actually using those in the compute behind the scenes. So don't need to write those out the disk every single time. If things haven't changed, we'll just use them and crank through it super fast. No muss, no fuss. All right, let me keep on rolling. I want to also show you guys some spatial results enhancements. So I'm going to switch. No, I'm going to stay within this one. All right, so let me go to this simulation. I'm going to actually compute it. First and foremost, I want to show you where you get the spatial results. I've shown this before. That hasn't changed. If I go to the compute tab, you guys still hear me? You got a note from Simon that things froze. Everybody still out there?
Yep.
Okay.
Mike, I can hear you.
Oh, cool. I will cut that out of the video. All right. All right, so say we got the simulation of interest. We click on that one. I have specified that, hey, I do want to save spatial results. By default, this will be on no, but I change it to yes. You can change the time interval to anything equal to or greater than the computational time step to output these spatial results. Let me turn off those precip gauges. We don't need to see that. And I want to actually compute those spatial results. So I go ahead and do the simulation. That'll run through all the computations. This one's just using straight grids that I had created through external processes behind the scenes. And then that'll actually write out the spatial results of interest. If you were paying attention, you saw that there were a couple of other things that were actually showing up within the interface. I'll actually make that a little bit smaller so I can bring it to the forefront. We have added a legend, a north arrow, and a scale bar to the interface. And you can selectively turn those off. So say I don't want to show the scale bar, I just want the north arrow. Or I don't want the scale bar, I just want, I don't want the north arrow, I just want the scale bar type of thing. You can do that. You can also move them. So if you want to edit that, you can say where I want them to be in the upper left, whatever. This works really well for the Truckee, but the Truckee looks like this. Not every single modeling domain looks like that, whatever. We also have a legend. And the legend becomes active when I actually select a spatial result. So say I select SWE, now the legend is actually going to draw for me and say, these are the values that you're actually looking at, along with the color coding and everything to see in here. This value I set, the 50.676 inches, I set because that was the max that I was going to see throughout this simulation. I've shown you before where you can hover over the spatial results and see what the specific cell values are. So if I turn on discretization, this is how fine of a scale we're actually showing these results, and I'll zoom in a little bit. So if I hover over this grid cell here, this one contains 21.66 inches of SWE at this time step. And right now I'm at the first time step. So if I moved along, I would actually see that these change. I can right click and say plot spatial results, and that would get a plot of the actual time series of values for the selected spatial result at that specific grid. But now we have this actual legend. that's shown in here. So it gives a little bit of an indication of like what's going on. So if I wanted to capture this and use this in a report or whatever, I want to just make sense of the values that I'm actually seeing, the legend will help you here. We've greatly expanded, the royal we, Nick again, Nick Van to the rescue, has greatly expanded the capabilities of showing or changing the way that this raster information is displayed. So if I go to symbology, now I can actually change the way, like through classified or stretch. Stretch is typically what we're going to use with these, but that's not always the case. It's result specific. So maybe I wanted to look at cumulative precipitation, right? We have a very usual color code that we want to use in here, right? So this is what the National Weather Service uses to demarcate colors. Like pink means it's 50 inches or greater. So we select that by default. You don't have to use that if you don't want to. So if you want to change that from classified to stretch, you can jump off of the method, which is specific to precipitation. So we call that precipitation NWS radar. You can even change the values if you want to. If you want pink to mean something different, you can go in here and change it. If you want the label to be different, if you just don't want it to say greater than or equal to 50 inches or less than or equal to 50 inches, you can just say like, this is a lot of precipitation or something like that. That would show up then within the legend over here. You can show that way. Oh, min-max. So yeah, this would be a good one. We added min-max buttons. So if you want to see minimum for cumulative precipitation 0, what does it matter? But if I want to see the maximum precipitation that occurred within that simulation, regardless of time step, so I'll just zoom out a little bit so you can see, that goes to it. There is no time step at this point. So if I look at that specific grid cell here, that's 13.7 inches of precipitation that fell within that grid cell. So if I plot the spatial results, that is the value that fell at the very end. Sometimes that might be, depending upon the variable, it might be in the middle of the simulation, but we're just going to grab that and use that for you if you plot max or min. We've also added these buttons here. So the one on the left, the one that's in pink, captures an animation for you. Right now, that's just going to output an MP4 file for you, given the actual thing that you're displaying within the interface. So this will actually show the basin model as is. So you would get the element icons, you would get the terrain, you would get the grid, you would get the spatial result, you would get the legend, you would get all that stuff in the actual output animation file. Basically, if it's shown in here, you would see it. This guy right here, the black one, is essentially a snapshot. So that says, I want to export the current time step or the min-max, whatever. I want to export what you're currently looking at, just the spatial result, to a georeferenced TIFF file. So if you wanted to open that in ArcGIS, you can do that, or QGIS, whatever, that would be available for you there. I'm going to add some UI components that go onto that in the near future. Everybody hold me to that one. Don't let me forget. I want to do that. But those will be available for you guys to use within beta 10.3. It should be out very shortly. All right, last thing, and I want to give it over to Simon to show all the cool stuff that he's working on, is the statistical metrics. So this has been asked for in the past for sure. I wanted to see it in the past, right? A visual representation of how well you've calibrated. Obviously, you can look at, so if I want to, not spatial results, I want to select this guy, and I want to plot that one. You've been able to look at plots of time series at the specific location. You can pull up summary tables. We even include summary tables for the entire simulation for like every single computational point. So let me go to all computational points, and you can see RSR, NSC, percent bias, R-squared for like all across the board. And these help you to evaluate how good your model is actually performing. But what if you wanted to see that? You wanted to visualize that? Well, now you're able to actually go down to here, and there's flow NSE, flow P bias, flow R squared, flow RSR. So if I wanted to see Nash Sutcliffe efficiency, this is how well my model is doing visually. And the colors that we associate that come from a report from a bunch of researchers. Moriasi was the lead researcher's name. But in that, they've basically quantified like, here's good, here's bad, here's what very good means, here's what adequate means, and whatever. And we throw red is bad. If you're less than 0.5, we're going to make it red. If you're in between 0.5 and 0.7, we make it orange. In between 0.7 and 0.8, light green. And in between 0.8 and 1, dark green. You can change those values. You can change those colors, whatever. You can do a whole bunch of different stuff with it. But we're actually showing you in a visual representation, like this is how your model is performing for flow. If you go to a simulation that actually includes SWE, so let me go to this guy. So this is another one where I actually had observed SWE, and I compute that real quick. I can see how SWE is calibrating across all the subbasins within the modeling domain. So once that guy has finished computing, I'll select the SWE and scroll down, and here is how SWE is calibrating. Not so good there. It's less than 0.4. Probably want to work on that one. But it is good over here. I have a 0.92 Nash-Sutcliffe efficiency over here if I wanted to see P bias R squared and RSR for SWE as well. For every single subbasin that has observed data, or observed SWE in this case, let me show you that one. Hopefully you guys are as pumped up about that one as I am, because I've always been looking for visual representations and took a whole lot of Excel work and then a whole lot of ArcGIS work to make maps like that. But now you can actually create that within the HMS user interface. All right, that's good for me. Simon, you out there?
Hey, Mike. Yep, good to take over.
Yeah, dude.
All right.
Have at it.
All right. I have had Teams crash on me twice so far, so hopefully it goes smoothly here. Hi, everybody. My name is Simon Evans with HEC, and I'm going to walk through the new default snowmelt plots that we have in HMS 4.10. So this plot is a great new resource for forecasting. So you have all for each individual subbasin, you'll have all the time series needed to help with calibration. So there's two ways to access this new plot. And the first one is through the basin map. So this watershed's example from the Baltimore district, upper Susquehanna River. And I've already run through the forecast. And so I'm going to go ahead and right-click on one of the subbasins. And looking at the view results, we have the classic table, but now that you see there's a new option, so snowmelt graph. And this will show up if your forecast or simulation has a valid snowmelt method. So if you're using gridded temperature index or one of the other options, this will show up. For other just rain precip forecast simulations, it won't show up at all. So ahead and go and click on that. And here we are. So we now have, this plot will show up with the precip for the subbasin in the first viewport, the air temp for that subbasin in the middle one, with the PX for that subbasin and the base temperature. So those are two parameters in the snowmelt or gridded temperature index and then temperature index methods. And then also at the bottom of this third viewport, we have SWE depth, so computed in blue. And then if you've hooked up a observed SWE for that subbasin, that'll show up as well. And just a reminder, from the subbasin, you can go to options, and now there's that observed SWE, so you can link a time series if you have that available. So this is a great little plot. So if you're doing real-time forecasting in a snowmelt watershed, and you want to get into each individual subbasin and see, like, okay, how's my SWE looking versus the observed? You can see in this example, it's a lot of rain coming, and there's a big rain on snow event with the higher temperatures, and you see the SWE just going to fall off and have a high inflow or high outflow from the subbasins. All right, so the other option to access this plot is from the results tab. And you can go ahead and click on the forecast. And then for each subbasin, you can see you have the normal or the traditional graph, and then now you have the snowmelt graph. And it's same plot, just a different way to access that. All right. Yep. So hopefully this helps out with the forecasting as you go forward. And any questions, just let us know. All right, Mike, you ready to take back?
Yeah. Thank you, Simon, for adding that. That is a huge improvement. What I used to have to do when calibrating snowmelt was to go to the results tab, select on the subbasin of interest, select snow water equivalent and observe SWE, and then temperature, and then precipitation, and plot it in a new plot. And then I couldn't really change any of the viewports and whatever else, and it was kind of tough to work with. And every single time I would compute, it would change line styles back. What Simon has done has automated that and made it a whole lot more useful, right? So you should be more comfortable calibrating temperature and calibrating SWE, making informed decisions as to what your parameters should be. Similarly, it still stinks when you make a change to a plot and we compute and we change it back to some default color. We don't want that to happen. We got frustrated by that. We also didn't really use a whole lot of the options that were available within plots, within the library that we were actually using. For instance, what if I wanted to actually change it to the log axis? Now I can actually do that. Dude, how nice is that to actually look at it from a log axis? Now I can actually visualize slopes or changes in slope on the actual recession side, so I can make an informed decision about what my parameters should be and focus in on the areas that I want. Similarly, if I wanted to click on an element within a plot and highlight it, now I can. This is computed outflow. Or I can say, here's observed flow. Or how many times have you been like, oh, that's the outflow from that specific element, but I don't know which one it is. It's kind of hard to see and whatever else. Well, now like I can actually click on it and you get the same action that you would expect from all these plots, right? Also, what really was a bummer in the past was like I couldn't zoom in on an area and then recompute and have it stay where it was zoomed in before. So say I was like, I want to figure out whatever, I don't know what flood stage is, but let's just say that flood stage is like 9,000 CFS at this location. I can add a marker line now into these plots. So I'm gonna go ahead and edit those properties. I'm gonna say flood stage, and I'll make that bold, and I'll make it 14, and I can put that to the left side of the plot, and that's great. And then maybe I want to make that dashed and a little bit heavier. Cool, I can change the color of that too, whatever. Things that you're used to being able to do within a plot. Now I can edit that. That's great. What I really, really want though is when I go and compute, I think this is for Reno. Yeah, so I'm going to go and compute Reno, and we're not going to change that plot. We're not going to zoom out. We're not going to get rid of the marker line that you got in there. We're not going to change any of the line styles that you got in there. The plot stays as it is. So very, very nice quality of life feature. And that works for any plot across the board that you can create. So this is just a simple one that you open using the view graph button. But if you wanted to make a own custom plot of temperature and LWAS and whatever else, you can do that. You can even add viewports. So I can go up into edit, configure plot layout, add viewport, and then move things around and do whatever else that I want to go with it. And we keep that plot the way that it is every single time you compute. So I am very excited for that. It's a very simple thing that we should have been doing for years, but that wasn't always the case. All right, let me bounce back over here. So that was demo of new features, things that are going to be available for you either now or in a couple of days when we get beta 3 out within version 4.10. Here's some stuff that's coming down the way that I want to make you guys aware of. First and foremost, we are migrating the snow methods from the MET model to the basin model. This is something that we've wanted to do for years. It's so much easier to manage all this information because it is a basin process. It's not a meteorologic process. What we do with actual snow and stuff like that, how it melts and how it interacts with the actual subbasins, makes sense to be within the basin model. And this opens up a lot of stuff for us. We've reorganized the way that the meteorologic model computes to do this. So we're realizing the benefits of all these years of work, getting it there. That means that you're now going to have a new tab. If I selected my subbasin, it's called Rogue in this case within the basin model. You're used to having a discretization tab, a loss tab, a transform tab, a base flow tab, all that stuff. Well, now you're going to have a snow tab. You'll be able to select or define your parameters on here. If you go to your subbasin tab, you'll be able to select the actual modeling processes, whether that's regular temperature index, gridded temperature index. We have hybrid RTI that's coming along, and regular energy balance and gridded energy balance. That'll be there for you too in future versions. This will also make some changes to the way in which things used to work. So if you had many subbasins or many basin models that link to a single MET model with temperature index snowmelt going on, we don't have to do anything funky to migrate to this new way of working with this. However, if you had, say, one basin model to 5 different MET models that all had different temperature index parameters, now we want those to be within the basin model. So we have to actually make basin models for you. This will all happen automatically. You guys don't have to do anything, and we'll let you know what we're actually doing when you open up the project and convert to the new model. But you'll actually see all these changes where they should be in here. So it'll be an informed decision. We're also going to add simple reservoir operations in the future. So I highlight the fact that it's simple, but you'll be able to do more than you've been able to do in the past. Really, really pumped about the precipitation frequency updates. So if you're like me, you dabble in a whole lot of different things, not just forecasting all the time, but you're doing a lot of other production modeling and other feasibility study type level of modeling. Precipitation frequency is something that you got to use to justify projects quite frequently, and we have greatly enhanced their abilities. We even had a new frequency analysis compute where you can actually do a simple set of computes, like it's a nested compute, to actually define what flow frequency or stage frequency is at a specific location. Even more complicated than that, if you want to actually use ensemble products, so many different possibilities of what the future would look like. We're actually going to add an ensemble analysis that builds upon the frequency analysis and allows you to do a whole bunch of cool stuff there. All right, just in conclusion, to highlight, the latest release that's on our website is 4.9. The current beta that's on our website is 4.10 beta 2, but there will be a beta 3 very shortly, if not this week, next week. We got it up there. Both of them work within the CAVI. You can use them within the CAVI, no problems there. Many new features and bug fixes within version 4.9. Not just new features, for sure. We like adding those, but we fix a lot of bugs that come along the way. So I would ask that you update to version 4.9 when it is convenient for you to do that. Many more enhancements are on the way, and we're constantly updating documentation and tech transfer materials. If you are interested in partnering with us and helping us with that, we would love to have your help. So please let me know if you're any at all interested in that. That's all I got. Let me take a look at questions if anything came through. I don't see anything in chat. Am I just hallucinating? Or do we not have any questions? Gotta have some questions out there.
No, nobody posted anything, but if anybody wants to unmute and ask a question, I think feel free to do so.
I just want to make a quick comment first, just to compliment you on the features you're adding here. The grids, the interpolated grid and whatnot, that's exactly what I'm working on right now on the Malheur in Eastern Oregon. And this is great. I do have a question regarding some of the features you showed with that, whether they were in the beta 4.10 or, because I don't remember seeing anything like that in 4.9.
Yeah, the interpolated meteorology is a 4.10 feature.
Okay.
That is in the latest beta, so you can get access to that and use it if you would like to right now.
Yeah, I think I will.
Okay, let me know how it goes. I appreciate the compliments. Thank you.
Yeah,
well.
And the other thing is it's kind of nice for me to see the January '97 event. I lived in Plumas County at that time for a long time, but anyway, to see your model of the Truckee is kind of interesting.
It was a bad one. I just finished the report for another effort on that. $2 billion in flood damages from that one. It's a wide-reaching.
That doesn't surprise me.
I do want to give a shout out, though. This is not me. HEC-HMS functions as a team. As I said, our team has grown by a factor of 3 over the past couple of years. So major shout out to all the team members. Tom Brower, Greg Karlovitz, Simon, adding a whole bunch of cool new stuff into it. Nick Van, Jay Pack, Matt Flemingsley, our division chief, is adding code all the time too. Josh Willis, Natasha Sokolovskaya. Let's see who else we got here. Help me out, Tommy. You on here? Don't let me forget anybody. Daniel Black. The team is huge. Lots of really good stuff that's going on. Very appreciative of everybody's efforts.
I think Alex Davis and David Ho. I think
there we go.
Nice.
I got stuff. It's a big team. It used to be just 4 people. Now it's bigger. Yeah.
We did have a couple more come in. Morgan asked if HMS 49 works in swims 322, and Matt McPherson responded yes. So just to make sure everybody saw that. And then we had another one come in from Jeremy that asked if SWE can be interpolated and bias corrected with a gridded product.
So we don't allow you to define point SWE and distribute throughout the modeling domain based upon that. However, you can use some of the features that are available within HMS to do some of the correction along the way. So if you wanted to, go ahead and show this again. So say I went through all the effort of defining my precipitation products, just to envision that this was an actual gauge interp setup in here where I was using interpolated precipitation and temperature. The grids are actually written to disk, right? So I can still use the tools data normalizer option over here to normalize that based upon whatever else I want. Or I can use grid to point to go back from grids to sub-basin averages, or I can clip them, or I can do some calculation options along the way. But unfortunately, we do not allow you to distribute SWE based upon point measurements. If that's something that you're interested in the future, maybe we can talk about adding a utility to do that. Let me know.
Yeah, thanks.
Anything from anybody else? Well, if you guys do have questions after the fact, we're always here. Post them on Discourse, please. Or I'm going to tell you to post them on Discourse anyways. Hit me up on Discourse. We'll all be able to jump on it and answer that question super fast.
Yeah, well, thanks again, Mike and Simon, for helping us today. Appreciate your time and effort in putting this together. Yeah, and again, feel free to post questions in Teams if you have any questions about the presentation. Mike, can you post the slides that you had just so people can have the links? Mm-hmm. When I post the recording after this, feel free to throw the slides in that folder as well.
Mm-hmm. I'll do that.
That way everybody can get to those sites and follow those links if they need to. But yeah, post on Teams if you have questions. And then if anybody from HEC asks you guys to post on Discourse, please follow up with that so we can keep track of things. I know there's confusion on where to go sometimes, but there's a lot of people that monitor both. So
we'll answer your question one way or the other.
That's right. Yeah, appreciate everybody's effort and support in both locations. So, all right. Well, thanks again, everybody. Appreciate your time, and hopefully we'll see you again on another webinar here in April.
Yep. Appreciate it.
Have a good day.
Thank you.
Thanks. Bye.